seated here in the Shekhar Hall so that we can begin with the next session. Securing turbulent waters, space-powered maritime strategies. This session examines the pivotal role of space-based assets in enhancing maritime domain awareness and naval operations. Expert panelists will discuss how advanced satellite technologies are revolutionizing blue water capabilities and extending the operational reach of naval forces. Key topics include the use of space-based ISR for persistent maritime surveillance, over-the-horizon targeting, and the optimization of naval C4 ISR. Communications, computers, intelligence, surveillance networks. The discussion will also address how these capabilities support anti-access or the area denial strategies to improve maritime security in contested environment. For the same, may I call upon the chair and moderator of the session, Vice Admiral Shekhar Sinha, PVSM, AVSM, NM, and Bar ADC. May I also call upon the panelists of the session. Commodore A.G. Singh, Vice President, Indian Maritime Foundation. Mr. Vinay Sinha, Founder and CEO, SkyServe.ai. Mr. Satish Raju, Senior Manager Industry Accounts, Apex Planet. Mr. Srinath Logasubramaniam, VP Sales, Reorbit. And Mr. Pramod Konagurthi, Senior VP Space and Data Engineering, Exilinks Lab. Over to you, Chair.
Can you start? Okay. Good afternoon, Jai Hind, Namaskar. Thank you, SIA-INDIA, for organizing this DefSAT conference and expo. It's an annual event, and I believe that it is quite successful. I've been once to see the expo a few years ago. Also, thank you, General Pannu, for inviting me to chair this session of the securing the turbulent waters, space-powered maritime strategies, and we are a set of outstanding people sitting here. They're all very professional. I am not a satellite professional, but I can give you a little bit of background, having served in the Navy for, 42 years, and not having seen all this very much. So everything is new. But we have come a very long way in the, modernizing the Maritime Domain Awareness Network, about which Commodore A.G. Singh will be speaking more, so that we can use it for communication, we can use it for data transfer, we can use it for picture transfer. Now, Maritime Domain Awareness is very, very important, because at any one time you got to know that which ship is where. And as somebody of my co-panelists were mentioning that it is 70% of the world is water. How do you monitor all this? It will require whole lot of satellites, whole lot of very high definition cameras, etc. But I leave it at that. Our panelists will cover. But what I am going to suggest to my panelists is that concentrate on the Indian Ocean region, because that is where our primary area of interest is, and it's not small. If you put your finger on the southern tip of Indian peninsula, we are looking at a radius of at least 1500 kilometers, right, which covers from, let's say, Gulf of Aden on one side up to Malacca Strait, or maybe even further down to the Lombok and Sunda. Now, we always wanted to talk to ships at sea, and the ships wanted to talk to you. So we were using a satellite, communication satellite, which was actually meant for maritime emergencies, and it was not owned by us. We didn't have any communication satellite. But we used to pay money. We used to hire it, and every call we used to make, we had to pay the money at the end of the day. And if you have to pass some very important message, then we used our cipher. We used to transmit the coded message, and then on the other end, it used to be decoded and sent. But as our desire to talk to ships and ships back, because there is no other method, and if you use anything else, it is liable to interception, and it can get jammed. Even HF can be found out. You can be people can home onto you, which you don't want. So in 2010-11, ISRO, I happened to meet Dr. Geeta Vardhan. That's what he said? Yeah. I met her and I asked her to come to IDS headquarters. I was heading the IDS headquarters as a CISC. And I said that we would need a naval communication satellite. So she said, why not everybody else? I said, no, that will become too much. Our own requirement is such, if I told you, then you will find that, why we need one. And specialists like AJ, Commodore AJ Singh and all, I called them. I said, okay, which bands do you want? So we gave her a task of Charlie band, Sierra band, Coup band, and a UHF. And she said, yeah, but the satellite will become very heavy because of so many antennas. I said, koshish to karo. And we funded the initial bit of, I think it was 32 crores to start the fabrication from IDS headquarters, not from naval headquarters. And later on, the Navy took over the case. And that was 2011-12. And as luck would have it, after that, I went as a Commander-in-Chief of Western Naval Command. And I was told that we have to take over the controls of GSAT-7. It is operationalized. So we took over control of the satellite in Bombay, Thane. And I made the first call to one of my ships, INS Deepak, a tanker which was new tanker, which was headed for Murmansk in the Barents Sea, because she was to escort and logistic support to INS Vikramaditya, who was on a maiden visit from Murmansk, not visit, home port to Karwar. First time that she was coming to India. So when I spoke to the CEO of Deepak, he was already in the Red Sea. So the declared radius of this satellite was 1500 kilometers radius around India, around southern tip. And Red Sea was even further. In fact, I spoke to him even while he was in Mediterranean. So it exceeded all the expectation. So we are always conservative in telling a good thing. So that is what happened, and now of course we have come a long way. I'll stop my talk here, otherwise I can carry on. Hardly get an audience to listen to me along. First, I'm not going to introduce them, and they will just tell their name and what are they doing in one line, and speak for about 3-4 minutes initially. On my left, 1, 2, 3, and then coming back to right. Once they have all finished, then amongst ourselves we'll shoot questions to update ourselves, because everybody is meeting each other for the first time, I guess. So what is your organization doing? Having done that, amongst the panelists, this discussion gets over, then we'll open it to the audience. And then you can shoot your question. Who have you question for? Name the panelist and we'll take on. So thank you, and there we go. AJ.
Thank you, sir. At the outset, please let me apologize for my bad throat. I'm croaking more than speaking. But nevertheless, I'll try and keep it as clear as possible. Well, good evening to all of you. It's a privilege to be at the DefSAT and share my thoughts on how space-based assets can play a pivotal role in enhancing both maritime domain awareness and the sustainable exploitation of the maritime domain, which is very important. Thank you, SIA, for this opportunity, and General Pannu. As has already been brought out, space is the new frontier, and the race for the domination and weaponization of space is going to figure very prominently in the 21st century strategic discourse. From a maritime perspective, historically, The sea has been the medium for the rise and fall of great powers, with maritime supremacy being the key to global domination. The 21st century is no different. This century is widely regarded as the century of the seas. With the rapid depletion in land resources, the world is turning increasingly to the oceans for its economic well-being. The oceans are going to be the scene for future cooperation, contestation, confrontation, and conflict, not just for power and prestige, but equally for the resources hidden in its depths. Indications of this are already visible in the Indo-Pacific, with the Chinese belligerence in the South China Sea being a cause for great concern. In our globalized and interconnected world, particularly in the Indo-Pacific, more than 90% of global trade and almost 80% of global energy travels over the sea, connecting every part of the globe. Ensuring the safety and security of this trade and energy is essential for the smooth functioning of the global economy. The world is also passing through difficult times, with 2 ongoing conflicts and numerous grey zone confrontations showing no signs of abating. This is leading to turbulent waters, as the theme of this session suggests. The last 2 decades have also seen a shift in the nature of the maritime threat. While classic state-on-state conflict remains the raison d'etre of navies the world over, the focus is now shifting more to the more insidious and asymmetric, non-traditional security challenges. These have no defined timelines. They are driven by ideology, political instability, and economic deprivation, and very often by pure criminal intent. While they are seemingly innocuous in scope and scale, they have the potential to disrupt the global economy. We all know the economic impact of rerouting ships around the Cape of Good Hope in the face of the Houthi attacks on shipping transiting through the Red Sea is already impacting the global south. Piracy, maritime terrorism, contraband and narcotic smuggling, human trafficking, gun running, insurgencies, marine pollution, and illegal, unregulated and unreported fishing, also referred to as IUU fishing, are just some of the areas of concern. As for the Food and Agriculture Organization, IUU fishing alone accounts for more than 20% of the global fish catch, running into billions of dollars every year. Added to these are the effects of climate change, which is leading to an increase in the frequency as well as the intensity of extreme weather events in many parts of the world, and more so in the Indian Ocean. Many small island states and low-lying coastal states are faced with the existential threat of inundation due to the rising sea levels caused by global warming. Adequate warning and measures to mitigate these are critical areas of concern. Flora and fauna in the marine biosphere is facing unprecedented challenges due to rising seawater temperatures and acidification of the seas. It is also leading to the migration of fish to cooler waters. This in turn is affecting the livelihood and sustenance of coastal communities, particularly amongst those who are economically vulnerable. All of these, individually and collectively, have an impact on global security. Having provided this brief overview of the challenges facing the maritime domain, let me now turn to highlight how space-based assets can help us understand the oceans better and be the great enabler to address and mitigate some of these concerns. The most common use of space-based assets in the maritime domain is basically for position, navigation, and tracking, and is being used since many decades. As Admiral Sinha mentioned, we all grew up in the age of the Magnavox, when there used to be one satellite navigation system on a group of ships, and that too used to give a navigational fix at predetermined times many hours apart. We've come a long way since then. But GPS signals are also vulnerable. They can be jammed and can throw shipping traffic in disarray in narrow restricted waters. The use of satellite-based augmentation systems has further improved the accuracy of navigation, position, and tracking. A SBAS augments primary GNSS constellations by providing georanging, integrity, and correction information, thus enhancing navigation accuracy. The second important application of space-based assets is as a means of communication. Satellites provide for very effective ship-shore interaction. Besides the direct connectivity applications for telephonic conversations, etc., logistic support systems and financial information systems ride on this backbone for enhanced logistics management and command support functions on board ships at sea. To enable secure satellite communication, India too is investing both time and resources in developing its quantum communication capability. I understand ISRO is also incorporating quantum communications in its space missions to ensure space-to-earth communication channels. A second aspect of communication is to transmit a situational awareness picture from other sources. Information uploaded by ships on deployment, maritime patrol aircraft, unmanned aerial vehicles, bistatic and multistatic sensors, and other sources like shore-based coastal radars, lighthouse sensors, vessel traffic management systems, and AIS information on the movement of ships, etc., are collated and analyzed at the information fusion centers and thereafter transmitted through satellites to the units at sea to provide them real-time situational awareness. India's sound maritime credentials as a preferred security partner and a first responder in a crisis are greatly assisted by its ability to get timely information and react with alacrity. The third and one of the most important functions of space-based assets is to enhance maritime domain awareness through their ability to carry out surveillance over vast swaths of the ocean. The term MDA came into prominence after the 9/11 attacks in the US, when the US realized that they were equally vulnerable from the sea. And over the years, in the last 2 decades, MDA has become a very important and very widely used term in the 21st century maritime security lexicon. Maritime awareness is actually a very broad term, and the IMO, the International Maritime Organization, defines it as the effective understanding of anything associated with the maritime domain that could impact security, safety, the economy, or the environment. Space-based assets can provide valuable information on each of these. However, in the limited context of maritime security as we understand it, a more appropriate term would probably be maritime situational awareness. Satellites are ideally suited for ISR missions, intelligence, surveillance, and reconnaissance, in the maritime domain, as they are not visible, are relatively invulnerable to a counterattack, and can collect vast amounts of information. Satellite-based surveillance through a wide range of sensor payloads, including synthetic aperture radars, satellite-based AIS, multispectral and hyperspectral optical sensors, and GNSS reflexometry, is enhancing the quality of the maritime picture in areas where conditions do not permit the installation of traditional systems. In these cases, satellite-based monitoring and surveillance is of particular value. Satellite-based AIS is also a revolutionary technology to obtain a comprehensive and global picture of maritime traffic, including that of areas which are far from ports and ashore. It is also a very useful tool for detecting criminal activity at sea by persistent monitoring of vessels to track their activity even if they disable or switch off their AIS transponders. The fourth enabler, is space domain awareness. This underlines the effective use of space by tracking the movement of every satellite, debris, etc., and every object in space, and thereby monitoring any abnormal activity like the trajectory of a ballistic missile. The US, of course, leads the world in SDA. In India, we're still in the very early stages of developing this capability. A recent area of concern in the maritime domain is the vulnerability of undersea cables, which carry 90% of the internet. The ease with which these are now being damaged by simply dragging anchors over them is scary, to say the least. Maybe we need to find a space-based alternative to ensure unrestricted global communications. I have deliberately not covered the kinetic dimension of space-based assets, but the weaponization of space is a very real concern. India too tested its ASAT capability a few years ago. Military activity in space is bound to increase, which would require some kind of international regulatory framework to ensure a semblance of order in using space for military purposes. To conclude, the space and the maritime domains are going to shape the future global order. Countries with space and maritime capability will be the future powers, and those without will not be powers at all. Thank you.
Thank you, sir. Thank you, SIA, for having us here. Hi, my name is Vinay. I'm CEO and co-founder of SkyServe. SkyServe is an edge computing company that delivers information, be it for communication or for data, from the satellites to the vessels or objects of interest. When we look at change, we look at two aspects. What has changed or what's the current status? And when we look at the maritime, when Sir talked about 70% of the planet is filled with waters, that's one of the biggest opportunities, apart from it being a challenge. Vessels don't have enough connectivity. Vessels, most of the time, ensure the routes that we go in are supply chain resistant. They perform ISR maneuvers. They also ensure that they are some sort of a deterrent to ensure there's less impact for the supply chain. Each of these vessels have a bunch of sensors as a part of the ISR capabilities when they look at it. These sensors are capturing a lot of data. When you capture a lot of this data, the data is highly localized, and the information that's going back to the NOC or the Mission Operations Center back at the land takes its own time to communicate. How do we solve for these challenges? And when the satellites look at the maritime positions, PNT is a big challenge. As they moved by quite a few knots, the accuracy of it, the transmission of data, the quality of it makes a key role here. So we at SkyServe are looking at solving these challenges where we are localized our edge computing to make the vessel intelligence stack to be smarter by processing a lot of information which is relevant for the user and sending it back to where it matters. Make sure our supply chain is resilient. Make sure our routes are safe, whether Straits of Malacca or other areas, which is one of the busiest shipping areas that we see here. Also, from the satellite, when it sends a communication, how does all the data, how does it become secure, how does it become persistent, how does it become unique at every point of time? And that's what we are doing here. We hope to contribute to the Indian solutions as an indigenous company as much as possible.
Thank you, Vinay. Satish?
Yeah, thank you. Thank you, SIA and DefSAT for having us here. So I am Pramod, Pramod representing, I'm Senior Vice President at XD-Links. So coming to the profile of our company itself is we provide satellite as a service, ranging from all the way from nano satellites to all the way up to micro satellites. And we have 5 standard platforms and which can be used for all the ISR solutions. Apart from satellites, we also make payloads, EO payloads ranging from 3-meter resolution GSD multispectral to all the way up to 0.5-meter resolution GSD. And we are also into hyperspectral payload manufacturing, and that is going to be done later part of the year or maybe early part of the next year. So this is as far as the XD-Links is concerned. Coming to ISR and maritime surveillance solution itself, as rightly pointed out, the 70% of planet is covered with waters, and the space is the only way we can actually do the surveillance or monitor this entire vast area which is largely covered with water, and then activities which happen is really dynamic and also happen very fast, because unless you continuously monitor these areas, so it is very difficult to really address this space security issues like terrorism and illegal fishing, etc., like pointed out, all these kind of activities which take place in the oceans. So the biggest challenge here in this part is going to be the large area, how we cover with these limited satellites, and how much of data it is going to generate, and that the information extraction, which is going to be very, very crucial, and it has to be very small 0.001% of information which should be probably useful, that has to be really seen and monitored. And that is the biggest challenge as far as maritime surveillance is concerned. You have a lot of data, and the percentage of information which you are going to generate, vital information, that is going to be very, very less. And that's the biggest challenge at XD-Links. What we provide as a solution to these kind of problems is we do a lot of onboard processing. When we have in our platforms, we have onboard processing, as Vinay was also mentioning. Edge compute is the biggest thing, which or very essential part of it should be there unless you have that kind of processing capabilities right at the sensor level, processing on ground, getting the data onto the ground, and then generating this vital information is going to be a biggest challenge. Unless you provide onboard processing and intelligence, this is going to be very difficult, and that is what we try to do it at XD-Links. And as we are also saying that in maritime surveillance, one is the observation, earth observation. The second one is the PNT. PNT is also the biggest challenge, because unlike ground truth is available, and on the ground you can really correlate to the features and other things. But when you talk about precision targeting, etc. on in seas, it has to be very accurate. And you don't have any reference system there, a reference for that. So that is the biggest challenge. And of course, you also have to fuse the data with fused data like AIS or maybe other source of information like maybe other sensors like SAR and other things which are going to be, of course, the other challenge is going to be the visibility. In oceans, most of the times it is also covered with cloud. So EVO sensors also pose their own challenges on the visibility. So sensors like ELINT and even SAR and such kind of those things had to be really positioned in space, and space is the only way you can actually monitor this large area, and that is very essential. That's all. Thank you.
Well, thank you. Firstly, sorry, I got the name wrong, mixed up. Pramod. Just for knowledge, Dr. Pramod is a former scientist of the ISRO. He has served there for more than 20 years. And then you can shoot a lot of questions to him what is happening. I will have 2-3 questions myself.
Thank you.
So hopefully that, Satish.
Yeah, good afternoon. My name is Satish Raju. I represent Planet Labs in India. I think I'll start with referring to a couple of incidents that were reported in the last year or so. There was this well-reported incident of transfer of armaments from North Korea to Russia. And one of the means of doing so was ship-to-ship transfer. So a lot of containers, probably containing armaments, getting transferred. The remarkable thing about this is that the AI systems were turned off in both the ships. Obviously, neither of the countries wanted these to be visible or reported. Yet they were detected and widely reported. The second incident, and this will be touched upon by my colleague Erika in the tech brief session tomorrow, was where one of the cargo vessels reported its location as being just off the Indian coast, but its actual location turned to be off Bandar Abbas in Iran. And again, so this is the case of AIS spoofing. Now, in both cases, Planet data was used. What Planet does is near daily imaging of the Earth's surface, both land and water. We have a constellation of, I don't know the actual number to be honest. The satellites that do the daily imaging is probably around 130 to 150 today. It will go up by another 36 next week during a launch on Jan 14th. These satellites have a short shelf life of 3 to 5 years. So to date, we have launched over 500. The value of these 500 satellites is the fact that there's a rich archive going back to 2016, 2017. So ships keep moving about, but when we talk about maritime domain awareness, we also talk about ports and harbors and warships and the like. And it's very important to establish a baseline of activity going back several years when you want to establish change detection. So whether it is dark vessels who turn their AIS systems off, whether it is AIS spoofing, detection of illicit or clandestine activity, our data does play an important role. And Pramod referred to the fact that we have vast amounts of data and we need to look at solutions. And this is exactly what we do both in-house as well as with partner solutions. So who bring in other data sets. So ours is just optical imaging. But our partners bring in RF data sources, aerial photography, and so on. And they have a strong database of vessels as well. So even if in the case of dark vessels, they are able to carry out vessel classification, vessel attribution, so going down to the year of manufacture, length, dimension of vessels, and so on. So this is the near daily imaging power of what Planet can do, and coupled with that is a constellation of high resolution satellites providing imaging at 50 centimeters as well. The issue with high resolution satellites, not just with Planet but with other providers also, is that there is gap in frequency and coverage. There's just not enough of them to be able to image the immense waterways that cover our Earth's surface. So the ideal way is complementarity, use daily imaging, detect change, focus on areas where you want changing and task satellites for getting higher quality imaging. Happy to talk more about it, but I think this is an important kind of data source to improve maritime domain awareness. Thank you.
Thank you, Satish. That's very, very informative. In fact, I will have many questions on the dark context, if you like, and how do you classify, because that has been our challenge at sea quite some time. We'll turn to our last speaker, Srinath. Yes.
Yeah. Good afternoon, and thanks for the opportunity, SIA and DefSAT. Can you hear me now? Okay. Good afternoon. Thanks for the opportunity, SIA and DefSAT. I represent Reorbit. We are a satellite manufacturer. We focus on critical comms and secure comms solutions. So we provide geostationary satellite manufacturing as well as specific comms manufacturing for maritime and defense special use cases, which is critical encrypted communication. People touched upon three areas of maritime surveillance, which is ISR, PNT, and comms. Our focus is on comms, and one of the areas which is critical on comms is how quickly can you get the data down to the vessel or down to the command center. So I will touch upon two examples here. One is the ISR. You have a lot of satellites orbiting the Earth, and there is data captured from the satellite using optical payload or a SAR payload. But it is very critical that you need to get the data back to the Earth through using a ground station. So the current problem or current situation in some of the cases is like you have to wait until you have the contact pass generated with the nearest ground station. And the time to this can be anywhere between 2 minutes to 2 hours or even 6 hours, depending upon where is the nearest ground station and where do you have access to. Coming into specific maritime and defense capabilities, these are all sovereign capabilities. And since it's called sovereign capabilities, some of the countries doesn't have access to this ground station maybe in 3 hours or 4 hours. So although you have the data, it's very difficult for you to get the data back to Earth so that you can use that intelligent information to act upon it. Reorbit wants to address this problem, and one of the way we address this problem is building satellites with inter-satellite links. So any satellite that we build will have inter-satellite links, and with the inter-satellite links, we will be able to bounce data, not just in the LEO orbit, we can also bounce data into the MEO and GEO orbit, and try to get the data delivered fast to the command center or to the vessel so that the data that is captured is as real value because the information has not changed. So this is one area of expertise that we have. The other area of expertise is completely core to Reorbit, where we have developed a software-defined core for geosatellite manufacturing. So if you look into the traditional geosatellites, they are somewhere around 4 ton, which is like 4,000 kg satellites, which cost you a lot of money, and it also takes a lot of time to build it. Currently, the time is estimated anywhere between 4.5 years to 5.5 years. We want to reduce the time to manufacture, so we are focusing on small geosatellites, which are roughly about 1,000 kgs, 1 ton, which can take up to payloads of 250 kgs, and the payload can be anything. It can be a Ka band, Ku band, X band, and any specific payloads like quantum distribution as well. And we want to bring the manufacturing cycle down to 30 months roughly, 30 to 36 months, which is easy access, and we are also driving the cost down. So we are significantly driving the cost down, maybe I would say to somewhere around 30 or 35 to 40% of what a large geosatellite would cost you. Yes, there is a compromise on the capacity, but one of the things that countries have to look into is how much capacity is good capacity. You can build a satellite with 175 Gbps or even 500 Gbps, but are you going to use all the capacity? So you need to have an optimization, and we do that optimization for sovereign capabilities. We also have encrypted solutions where we can provide you secure comms, which is very critical for defense and other areas. And one of the things that we touched upon is Indian Ocean. So I was thinking of a hypothetical situation, like currently there is a particular amount of capacity available in that particular, say, 500 kilometer radius of ocean. And suddenly there is a lot of activities happening and there are a lot of ships coming in. How does the capacity help you to communicate efficiently? Because the more ships, more communications, you need more capabilities and capacities and bandwidth. With our satellites, it's software defined, so you would be able to push more capacity by switching off some of the capacity on some beams and then transferring those capacity into those critical areas and providing immediate connectivity. The other thing which was touched upon is the undersea cables. So with the current situation, we see a lot of undersea cables being cut. Like there were a couple of cables cut between Estonia because of the situation that's happening. So when there is a cable cut, there is a need for immediate connectivity because your primary source of connectivity, which is the undersea cable, is cut. So we can provide, we have something designed in our satellites which are called steerable beams. So we will be able to move the beams if it's in the visibility of the satellite into that particular territory and then provide immediate secure comms as well as disaster management capability so that you are still able to communicate and you are still able to receive and transmit information back. So these are some of the technologies that we are working on. It's not specific to reorbit, but we have designed it in such a way which is more resilient, and we have also built in some redundancy capabilities which helps the new space market. So that's just a brief introduction, and we are based out of India in Hyderabad.
Well, thank you very much, Pramod. That was what I'll do is I'll open the house for questioning, but that will also include questions from the panelists to another panelist. And I being chair, let me take this prerogative of asking. Now tell me what happens in case of the in the downlink. I believe that the the message can be jammed by a jammer, not so much in the uplink. So that is one question. Second one is my own question which keeps bugging my mind. We have too many anti-satellite weapons, and what are we doing? Are we thinking that in case my satellite gets shot, will I be able to replace the the provision of another satellite or similar satellite, giving all that? So what I'll do is I'll leave this question open, and I think all of you can try. We'll start with you.
I will pick it up because this is right in our alley. So the first question is jamming situations that we discussed about. So that's why we talk about secure comms, and we talk about, again, there is a lot of work going on in this area. One of the research that's going on is quantum key distribution, where you can be very secure messaging, which is critical. And the other way we do it is we do have secure encryption, AES 256. So in that way we can secure the comm side of communication so that the encryption and decryption happens at both places. So we will have an encryption device on the satellite, and the end user modem will also have some decryption capabilities. And then
if it gets, the carrier wave itself gets jammed, it's not permitting, or maybe it becomes very powerful.
That's a very critical situation when that happens. So we are looking at the other ways of communication, which is the inter-satellite links and optical comms. So we are talking about jamming with a frequency point of view, where you know the frequency and then you spoof the frequency and jam that. That's why we are also building this inter-satellite link capabilities, which is optical comms. So we should be able to take the data, bounce the data, and then deliver it through different means or a different ground station into the system. But again, it depends upon where the jamming is happening, whether it's in the command center or in the vehicle, or which area it is concerned. So
Okay, I'm just giving you an offhand. Is there sufficient band of frequencies in one particular antenna where you can switch? You can have hopping of
yes.
You can have hopping of the frequencies.
Yes,
Is that possible?
so that's also possible because you currently have software-defined radio, so you can again hop between KU, KA, and then try to again there are frequencies that are specific to military band. So if needed, you can jump into the military band frequency also. So currently the technology is developed, and again these features should be developed on both sides of the system, both on the space as well as on the ground. So when you design the system, you should take these parameters into consideration, especially on the defense and maritime side.
Yeah.
And once you decide, you can have those encryptions done a bespoke design, and then the satellite is capable of switching between different frequencies, as well as the modem is capable of catching up those things. So the jamming can be avoided on the frequency side. On the other side, the satellites can also come with optical links, where you can send in optical information down
So I guess similar answer for satellite getting shot down. You can switch the.
For satellite shutdown, that's an interesting situation. So we will focus on the geo orbit because that's the very critical orbit, because you have a stable satellite, you know what it is happening and everything. So for this basis, that's why we are building satellites in a modular form. So we are focusing on small geos because you can build satellites modular. Instead of building a big satellite of say 100 Gbps capacity, you can build 3 or 4 satellites of 20 Gbps capacities and then position them in the same orbit. So even if one satellite is shot down, you will definitely create space debris, but you should be in a way make it redundant so that the other satellite still keeps functioning. And then if there are passive components involved, with inter-satellite links, you could be in a position to collect data from one satellite. With the inter-satellite link between the 2 satellites, you can bump the information to the other satellite and still send the information down to Earth. So again, this is something that is customer focused, and these design elements should be considered in the preliminary design review and understand what are the challenges that we will face, especially in defense and maritime situation. And given that the situation is getting, again, there is going to be more and more space assets, and space debris is a concern, and ASAT is also a concern. The people who are designing these constellations or a satellite should take these factors into consideration and try to build satellites on a modular form. Okay. And which is what Reorbit also recommends, building modular satellites rather than a big satellite. You can build small satellites, 3, 4, put them in line, have an inter-satellite link, and then you are independent. Even one satellite fails, you still have 3 satellites delivering the capacity.
You add to anything else? Not really.
No, I don't have anything to add because it's more comms related. Yep.
Yeah. So as far as jamming is concerned, what we do is we do this SDR. What he mentioned is SDR is built in our platforms, and we do if we detect something like that, and then we do a frequency hopping, try to change with a different frequency, and then try to do. But nowadays, with SDR in place, even the ground systems also switch and sweep the complete range, and then do the jamming as well. So one of the things which we can do is provide alternate bands, and then do a multiple beams steering. That is one of the options. Instead of having one frequency or a couple of frequencies, do the multiple frequency, multiple carrier downlink. So that is one of the options. And coming to ASAT and even the other satellite creating a problem or denial of service for you, that those could be like that we need to have a SSA in place, say space situation awareness that is in the loop. So once you have your satellite, you are detecting that it is in your orbit, so you take a corrective measure and then try to do the lowering of the orbit or something and the raising of that, and then avoid collision. So these are some two aspects which, but ASAT, of course, unless you have a better metrology and materials which really protect the satellite, right now I don't think we have any solutions for that.
Thank you, sir, for the question. So specific to ASAT, even if a satellite goes, I think the design of comm and data network should be having a HAIL plus LEO plus MEO plus a GEO, so that even if any of them at any point of time get compromised, you have consistent data and comms happening. So you cannot just rely on one asset or one type of communication system. At least you have different frequencies apart from SDR that Srinath and Pramod have been talking about. That's one. The second part here is as a plan B or a plan C that we talk about. If when we talk about quantum-based communication, it's important that it is just not about the chip. It's also based on how much all of the keys are already at AES 256, which is standard protocol. The range will be a concern. And then is there a possibility that you can do a hub and spoke model where if the vessel has to have this, can we go to a nearest hub? Can you use a buoy? Can you use others to go back and relay back what's critical? And these could also mean the most primitive ways of communication as well, which could be secure because people will always target newer technologies on a particular spamming or spoofing perspective as well.
Audience, the panelists are here. Please identify yourself. Keep the question short, and If you can say which panelist you want. Yeah.
Yes, sir.
This is regarding the frequency hopping. The frequency hopping should be fast enough that the enemy cannot keep up with it, and that's really the best solution for GEM.
So,
My name is R. Shekhar. I'm working with the Ministry of Communications in the capacity of Additional Director General of. So I have one question to my friend Srinath relating to the geo satellites with the limited capacity may help in terms of, say, reducing the risk. But at the same time, the concerns are that the geo satellite orbital slots are very limited. So once you limit the bandwidth, we are compromising with the available resources of the space. Is that right? Because we cannot have as many as satellites you wish. And India is already struggling as far as GSO orbital slots are concerned. So in that spirit, is it advisable to have the smaller capacity, or even to address the issue what is raised by Vice Admiral regarding the our jamming? It is more advisable to have the multi-band satellites, which has not been there traditionally, but now as a thought that you cannot go for a single band kind of the concept, we have to go for the multi-band satellites. Plus, I think in the normal communication, all of you will support me. We used to have the ring kind of the configuration. Or when we say the resilient means you have to have some alternate hot standby kind of the environment. So is it not advisable, whatever the satellite you plan today, each unit must have robust backup in terms of the hot standby takeover in any eventually detected? Your comments, please.
The questions are rightly put forward, and I think I need to clarify a couple of points. So the first point I want to clarify is the small satellites that we are discussing about is a multi-frequency satellite. So you can have a Ka band, Ku band on the small satellite platform itself. So you can have couple of antennas focused on and beams focused on a couple of Ku band beams, couple of Ka band beams, and if you can push the horizon, you can also have C and Q band beams. So the satellites we are talking about, and current in the current generation, the satellites that are manufactured are all multi frequency satellites. It will either have Ku Ka or it will have C Ku. So that's currently the standards in the market. So Reorbit does multi-frequency satellite, so we can do Ku Ka or C Ku. C is more out of the way, but currently most of the requests we get is on Ku Ka and X. We can get all three combined into the satellite. The other point that you raised about the orbital slot, which is again there is a finite amount of orbital slot, and there is no infinite amount of orbital slots. I'm not saying, and the orbital slots are constrained. My statement was, instead of building a big, massive satellite with all the bits and bolts in it, and then building a 100 GB satellite, build satellites modular. So you build a 20 Gbps satellite, launch it in the orbit, and I think if my max and my calculations are correct, you can co-host at least 3 satellites in the same orbital slot with a distance of, I really don't quote me here, but somewhere about a distance of a kilometer or 2, but I'm not a technically person, but you can host 3 satellites. So instead of having one satellite sat in the slot, you can have multiple satellites built in a modular form and then stored there. And 20 Gbps is just a example. So if you are planning to, again, it comes into your requirement. So if you have a need and you know that the demand is for 100 Gbps, go ahead and build the satellite. But my point was more on, like, even if you build a satellite for 100 Gbps and if you're not utilizing it, and then normally people, what they do is, I've built a 100 Gbps satellite, I've spent $500 million on it, so my per GB data is like $50, but it's not $50 because you're using only 20 Gbps of capacity. So your cost per Gbps is maybe $400 or $300. So that's where I'm coming into. So I would definitely recommend people to understand what is the need, what is the requirement, how much capacity we can build. And we are talking about a 10 to 15 year life cycle. And normally when you build a satellite, and everyone knows in this comms world, like it takes somewhere around 7 to 8 years to build capacity into the satellite. So you have 100 GB satellite, you launch, you start installing customers, you start installing VSATs, and the moment you install like 50,000 or 60,000 VSATs, that's when you are utilizing the capacity. By the time you have lost 7 years or 8 years of your time, which is underutilized. So I agree to your point. It depends upon what is your need.
This is Barjin here. When you say smaller satellite, what is the weight that you're talking about?
We are talking about 1,000 kgs, 110. So if you talk about a normal satellite, we are talking about 410 satellites or 510 satellites. Again, if you build a satellite, it takes much more time to build. It has the parameters to come in. It has to go through the testing, and it's also a costly affair. So roughly a 410 satellite or 510 satellite will cost you somewhere around 300 to 400 million. But if you are looking at a small sat, including launch, you can do it for somewhere around 100 million. And again, if you get your max rate, you can reduce the cost.
Thank you. No, you're right. I think you will correct me if I'm wrong. Our satellite GSAT-7 was 4 antennas, and I think it was 4,000 kgs or so. Correct? So I think the biggest rocket at that time put it in the orbit.
Yes. And again, it's cost effective to launch small satellites.
Yes.
Yeah, the point is right. Actually, what he's mentioning is right. So when we talk about the geo or GSO, this orbital slots are fixed. So, and it's a prime actually asset to have it in an orbit. We don't get a slot at all easily, that easily. So you don't want to lose the capacity by putting a smaller satellite and in that orbit. It's already there in that orbit. So that is.
When I see you jumping with your mics,
I've been an advocate of having an ITU filing strategy for this, because if there's a finite amount of assets that you can put in each of these orbits, and if you have a 10-year horizon paid for a bigger geostationary satellite or a micro geo satellite or a LEO or a MEO, I think India should put up a set of filings. Even countries based in Africa are filing for about 1 lakh assets to be put in space. They are not going to put that. It's either China or India who are going to back them. So we need to have a very clear ITU filing strategy so that this can propel, whether it's you're putting a 100 kilo class or a 100 Mbps or a 20 Mbps. We need to have those slots. We need to get that industrialization working with the government and putting those assets in space as quickly as possible, because that's finite and it's our time now.
Thank you. I just have time for one more question, if at all. Yeah. Yes, sir.
So just a comment on the co-location side, that co-location has to have on different frequencies, because
Yes.
at the end of the
Yes.
day, it'll be the ground station beam width
Yes.
that will decide how far apart they can
Yes.
be.
True,
Yes.
true.
Right?
But
So-
again, on the frequencies, you can have frequency reuse. If you are using KA, you can have reuse on RHCP here.
Not on the
LHCP.
co-located satellite, can you? Not on the co-located.
Not talking this co-located side,
Not
but
on
you
the
can,
co-located.
you can
Because
work on
otherwise the
multi-frequencies.
Earth station beam width will
Point-
capture
point
both of
taken.
them.
Yeah,
Point
So
correct.
then
taken,
you'll
sir.
have a problem there.
Point
Yeah,
taken.
correct.
Yourself, sir? Just last
Sir,
one.
sir, I'm Rajiv. I'm DDG of SIA-INDIA, sir.
Oh my God, okay. No, you have a very valid
Alexander
point.
Joik, I only wanted to make also an add-on. So if we are talking about fixed station, yeah, so it's 70 kilometers usually, which a geo-orbital satellite is the range.
Yeah.
So there is space for more satellites, and some of the satellite operators are doing that successfully, also with the big satellites like SES, for example, but with small ones that would work better even, yeah. Maybe a more dynamic approach, yeah, where you also don't depend on so much time to readjust the technology. The challenge is really, do you have the capability of manpower also to run these programs? And for some countries, yeah, it is, or satellite operators to run 3 missions in parallel is maybe more work than to run one big one. I think we should also mention
Hopefully India should not have this manpower problem for some time to come.
Okay.
Well, all that remains for me
Fair
to
and square.
thank the audience and thank my panelists very much for having done that. And obviously, big thanks to General Pannu, who has made this happen. He has got us all together. We didn't know that there are so many specialists who are working on the different satellites and normal satellites, because I just heard the previous one, the standards are going to be the same, because after all it is out in the open. Okay, you can code it, you can decode it, whatever you want. But I think that as an oldie in this group, I would say that we have really come a very long way from the day that we asked for GSAT-7, which ISRO launched for us with 4 antennas. And it was really a good start. So many thanks and God bless. Happy New Year to everybody. We'll all stand up and have a
Group picture.
I think we'll come closer. Yeah.
Thank you so